My name is Professor Leila Abubakar. I'm the Vice Chancellor of Technical University of Mombasa. We are proud to have the Innovation Week at Technical University of Mombasa, which is home for innovations. We boast ourselves of having a very, very vibrant innovation ecosystem within our university. Most of our students have actually been challenged and they've come up with a number of innovations. Some of them have competed and in the whole of Africa, and they have actually been #1. So most of our students, when they are studying here, we also make sure or we mentor them so that they can actually be involved in innovations, their ideas. When they have ideas, when they are young, they also have many, many ideas. So we culture those ideas and nurture them so that they can actually come up with worthwhile innovations. We have also had our students who are doing very, very well outside because of the innovations. Now, these innovations, as we are doing them, we also have our stakeholders who we are also involved. These are part of the industries. Like currently, we have a number of industries who actually are also collaborating with the Technical University of Mombasa so that our students can actually come up with these innovations. They do the facilitations. We also have Alliance Française, which is also another collaborator. And through these collaborations, our students have also been able to come up with innovations that are, should I say, solutions to our home, Kenyan homes or Kenyan industries. Thank you.
People suffer various injuries. For example, people who suffer from quadriplegic, multisclerosis, or cerebral palsy. These people, the only muscles they can move is up to their neck. Otherwise, their limbs cannot be able to move. They cannot be able to move even their legs, even their toes. So these people, they are normally subjected to wheelchairs, and for them to achieve locomotion, maybe from one place to another, these people require assistance, like all the time. Even when they are at home, they cannot be able to perform tasks and duties by themselves. For example, if he or she is in a room and wants to turn on the lights, she has to call for assistance. Come and turn on the lights, or come and turn off the fan. So I came up with a system whereby they can use their voice with just at a certain position fixed to the microphone. Whenever they speak a command, an action is being taken. For example, now in a wheelchair we have commands like forward, turn, maybe reverse. if they can just be, if with their comfort at the wheelchair, they can just give a voice command, and the wheelchair moves depending on whichever command they have given it. Also, it is also subject to also houses. The place that they stay in can also be automated using this system, in that they can turn on the lights using their voice. They can just say lights on and the lights will go on. They can say lights off and the lights will go off. Fans on, fans off. Water run and water stop. So this voice control system works whereby a command is given, and when the command is captured by only that single person who trained it, it can only recognize the voice of that specific person, in that when another person comes in, he or she cannot give the same command, and that same action can take place. That is now with voice recognition module. But with speech is the same as the one that we use in our phones, whereby if I can take your phone and use Google speech, I can be able to Google something. So speech gives space or room for different voices. But with voice, that same voice that was captured, it's the only same voice that can be used in a command. So even when when the user goes outside there, and maybe by coincidence somebody speaks a command that was trained, it will not be able to perform, because it is not the same tone as that of the same person. So with me here is a simulation of the voice control system. I have used an ultrasonic sensor. So whenever there's an obstacle in front, the wheelchair will stop. And these LEDs here can also demonstrating that when I put my hand like this, you see these red LEDs blinking, showing that there's an obstacle. So when I say a command like forward, it doesn't move. Forward, turn.
My name is Elizabeth Muli, a student at the Technical University of Mombasa, Faculty of Applied and Health Sciences, Department of Maths and Physics, undertaking a Bachelor's of Technology in Applied Physics, Electronics and Instrumentation. My innovation today is the sensor-based parking system for cars. Before I go on, I want to highlight some of the problems that I've encountered as a car owner. One problem that I've found out to be common among us is when you want to go to the mall, and maybe there's an event, or maybe it's during the weekend. You want to park your car, but you'll go through the parking area and find that there's no slot for you, and you have to leave and go to another mall or find another parking area so that you can come back later. Another problem that I've faced is at times you may park your car in the morning, but at the evening when you come and you want to leave the parking area, you are unable. This is because the person that has parked behind you has parked so recklessly that you cannot maneuver out of the parking area. And this gives you a lot of stress, and you're like, why should I wait for the person who parked behind me to come move his car in order for me to pass? These are problems that I, as a consumer, am not supposed to encounter at all. And due to this, I came up with a system that is able to tell you before you enter a parking area, will I find a slot there? And if the answer is yes, once I have found my slot in the parking area, how am I supposed to park? Am I too close to the yellow lines? Am I disturbing the person that has parked before me? Am I the person who is causing problems to the person that wants to pass and go to the other lane? I don't want to be that person. And that is why today I came up with this system, and I want to show you how it works. So I used a number of sensors and transistors and some lights. These lights are my actuators. In other cases, instead of lights, you can use counters or any other circuits that you find more applicable in your case. So my two boards represent two packing areas each, slot 1, slot 2, slot 3, and slot 4. Once the packing area is empty, my lights are off, and my sensor is sensing that there's nothing. So if someone has packed correctly, the lights will be on to show the other person that is supposed to come that that parking area is taken. And if you have maybe a screen or a counter system, it will show at the door that this number of slots are occupied. But if someone occupies when the person is on the yellow line, the buzzer will go off and it will keep on buzzing until the person parks correctly. So my message to students that are behind me is the number of cars is growing, and it's the dream of every person to own a car in future. But one thing you should also know is, in as much as we are bringing these cars, in as much as the production is large and people are buying more cars, this is causing a lot of pollution to the environment, and we should opt to other things that you can use to navigate, such as bicycles that do not pollute the environment, or maybe we can come up with electric cars, and also we can come up with more digital parking systems that are maybe story-like. Yeah, that is all for today.
Dr. Michael Saulo. I'm the registrar in charge of partnership, research and innovation at Technical University of Mombasa. As a department, our mandate is to promote innovation and community development. And so innovation to us is one of our main goals in the university. Technical University of Mombasa is a hub of innovation. And so having stemmed up from a polytechnic roots, it has very strong innovators. And most of the time, our students have been out there and have won different trophies in innovation. The innovation ecosystem in Technical University of Mombasa is so much connected to the 4 schools that we have in the university and the Institute of Computing. And so as the Department of Partnership, Research and Innovation, we are the ones that are in charge of the innovation systems within. We have 2 incubating systems, and so the innovation starts from the time the student is admitted at Technical University of Mombasa. That's where the idea is nurtured. Once the idea is nurtured, we have what we call an innovation club, where the student can be able to register. And once he registers in that club, he will be nurtured all through with his innovation. He can be able to develop it to a point where it can be commercialized. And that's why at Technical University of Mombasa, we pride ourselves as a hub of innovation at sea level. So we are telling our stakeholders that they should work with us in this Virtual Innovation Day as we try to exhibit everything that our students are doing. We have done much, but much is yet to come. And so whatever we'll be exhibiting today is not all that we do at Technical University of Mombasa. It's just a drop in the ocean. And so every year we'll be expecting to do much more, and we pray that our stakeholders will stand with us and will be able to support the ecosystem that we are developing. This ecosystem is supposed to go on and also touch the entire Mombasa County. As we well know that we are living at a very perilous time, a time of COVID-19, and so technology and innovation is the only solution that we have that can be able to help us come out of this pandemic and come out of some of the problems that we are being challenged with as a society. So thank you very much. We are welcoming you to Technical University of Mombasa because this is the place that you can be nurtured to be an innovator. Thank you.
My name is Vincent Mbugwa, and we are from the Faculty of Applied and Health Sciences. With me is
Martin Muturi, Washira.
Yeah, our innovation title is Solar-Powered Greenhouse Plant. And in solar-powered greenhouse plant, we entail at addressing the problem of food shortage and also in reliability of food supply in our community. As we know, weather tends to be unpredictable. Some year we end up having enough food. Some year we end up having no food at all due to drought. So with our innovation, it entails at least having production at 90% maximum, more than what we could have get from if we depended on the weather patterns. So it's also in line with our Kenya Vision 2030 in the sector of food and also the SDGs goals, in which we entail at solving the problem of hunger and also trying to create employment opportunities.
Okay, the plant comprises of a solar panel which provides cheap energy, which is then stored in the battery. And then we have a control box and a tank which stores water. On the tank, there is a water level sensor and a pump which pumps the water to the field. In the field, we have got the greenhouse. In the greenhouse, we have got two sensors, the humidity sensor and the temperature sensor.
So essentially, the operation of this greenhouse, we did set the condition to tomato plants. So it can be developed to be set in condition for other crops, but we chose to do it for demonstration on tomato plants. So essentially, we know that tomato require a temperature in between 17, but it should not bypass 35 degrees. So when it bypasses 35 degrees, it means the yield of the tomato plant will go down. So in our greenhouse, the condition set for tomato is that the temperature should be maintained between 17 and 33 degrees. When it goes beyond 33 degrees Celsius, we have the mechanism here of which it is being controlled by the setup in the control box here. And we have a field. In the field, we have a fan in which the fan automatically kicks in to regulate the temperature within the greenhouse plant. Essentially, in the operation of the greenhouse, it is done manually, in which when the temperature increases, you have just to go in and check it. You feel it for yourself and open if the door are there or the windows. But with this, you don't need all those activities, as it is incorporated with a fan, which regulates the temperature within inside. And also for tomato plants, we know that tomato require a soil moisture content in between 1 to 3 inches. So with me here is a moisture sensor, soil moisture sensor, of which it is used to sense the level of water or the water content in the soil. And when the water content in the soil bypasses the required amount, of which I said is 1 to 3 inches, when it goes below 3 inches, it means we need to rewater our tomato plants. So the pump here is set to automatically kick in and supply the water in the farm when it goes below 3 inches. So also, the temperature here is regulated by the fan. We have the humidity sensor, which should be placed centrally to take we can say the relative or the average temperature of the greenhouse, so that when the problem arises, it kicks the fan and the temperature is regulated. In the tank section, of which we assumed it should be placed somewhere outside, so you'll not be going there to automatically monitor it, in that you'll go check the water level at what percentage or at what level it is. No, you'll just be sitting at the control set point. It will be just like a room, of which we have a display here, an LCD display. It acts like your monitor or your screen on which you check the parameters within the field. The parameters within the field, of which the physical parameters, the water, the temperature, are just converted by the sensor to digital signals, of which can be displayed on the screen. So your work will be just to be checking on how they're varying. When the water levels goes below, in our case, this level, we did take it to an estimation of 3 centimeters. So when it goes below 1 centimeters, we have a pump of which it is connected outside and it will automatically refill the tank. So your work will just be to checking if the electronic gadgets are operating well. These 2 pails here represent our farm. This wet farm is when the soil moisture content is at its best, or it is at its set conditions. And this one represents when the soil is dry. So essentially what happens here is when the farm is well watered, it means that there will be no water running into the farm. But when the soil is dry, it means that we'll need to rewater our tomato plants for our case. So when you remove it, the water automatically kicks into the farm, and the water starts running to the farm until it is well watered. And it means when it is well watered, when it reaches that level, the pump automatically stops. You can see it as automatically stopped. So for the temperature part, here on the LCD display, it shows the temperature is at that. It means that the condition in the greenhouse is set. What about if it bypasses 30? We'll see what will happen. So the fan is running to regulate the temperature within the greenhouse and also the humidity. So when it goes below 35, 34, it should automatically stop. And also for our case, we realized that during the night, plants require light to photosynthesize. So we did set a light sensor here. It's an LED. So the light sensor, we did put it in the range of percentage, in that when the light goes below 50%, it means that the bulb inside the greenhouse will automatically light to also increase the temperature during the night when the temperature is below the set point, so as to rise the temperature to the required set. So as we are using the renewable part of energy, it means the continuous process that is running in the greenhouse should be equivalently cheap, because you'll not need to incur at the end of the month be paying for electric bill, but instead you'll be having your own source of energy. Thank you.
My name is Joseph Bodu. I work here at Technical University of Mombasa, and I am the one who is coordinating a project which is being sponsored by the French government and the Franco-Kenyan collaboration in higher education sector. And the name of this project is called Upgrading Diplomas for Industrial Purposes. Now, there are a number of activities which were directed to this project, and one of them was the robotics. And in the robotics, this is the one that which we have actually undertaken much has been done on the robotics, because first of all there was a training for 12 members of staff of Technical University of Mombasa in Nairobi for 3 days, where they were trained on the robotic programming. Then on the same project, there was another one to come, which you call it do it yourself. This was supposed to be done in France, but due to the problem of COVID, This has not been possible, but they're intending to have a virtual training for one day, and then later they can see how we can progress on this robotic training. Still on the same, there is also the 3D printing. And again, in this 3D printing, there was training in Kisumu for, again, 12 members of Technical University of Mombasa. They were trained on how to program the 3D printer. And again, they are also going to donate, which they have already donated one 3D printer, which we are going to see how it operates. Then there's also another training that is also intended. I don't know whether it will take place because of the same problem of the COVID, and this is on medical engineering. Again, this one we are intending, or they're intending to do it online through virtual training. But though we are coming to the end of the year, I don't know how we are going to make it, but we are hopeful that this is going to take place. Now, for the 3D printer, as I had said, 8 people are trained, and we have one of our trainees here who is going to demonstrate to you how it operates, plus 2 students, which she's also training on the same. So we are going to see that demonstration. Then we have also another person who was trained on the robotics, Mr. Mbaka, who is again with us here. He's also going to talk about the robotics and what the robot can do. And with that, I think I can hand over to them, and they can be able to explain. First of all, I would like, we start with the 3D printer, so that we can have the person who is in charge of it, Bibie, and she will explain to you what it can do, what are the importance of the 3D printer, and what are the benefits to such an institution, together with the students she is also training.
Douglas Mbaka, I'm a technician at Technical University of Mombasa. I'm here today to present to you a machine learning robot. Basically in front of me there are 2 of them, but they are all the same. They have all the features. The features of all, the 2 robots have the same features in terms of characteristics and what they can do. So basically, these robots are here to teach our students about machine learning, because it's the next thing in the market right now, making systems work on their own. No need of human supervision. Someone can simply sit behind a computer and get information from the system while it processes everything. So for example, the one I'm having in front of me, it has a basic camera so that it can be able to identify, and you can train it. The way we train students is the same way we train this. So you train it to do for you a certain purpose or a certain specific application. So it has a camera, number 1. It has a basic controller whereby it processes the data from the camera. Down here we have basic motors for movement, because it's a basic robot which has mobility. It has to move from one section to another section. We have a basic antenna where we can acquire GPS coordinates. We have ultrasound sensors so that it doesn't knock itself on objects. It can detect when it reaches near an object, it can detect and stop. On the downside, we have some basic sensors for basically directing it. Instead of now, it has 2 modes of control. We can either control it by using the cameras, tell it where to go, or we can use the line followers, which are down here, which have been fixed down at this point. So they can follow a specific line. You can tell them to follow a white line to a certain point, do something, and come back. So it has acquired this red color, and it's giving it a name of S is equivalent to 1. So if I remove this red color and I stand in front of this camera with another red color that I didn't train it, it will also identify. So at any one point, if it sees a red color, it will follow that red color. Now that comes in at the processing side. I've already trained the camera to identify a characteristic or to identify something. The next step should be for me now to tell this system, when you see a red color at some point, then move your motors to that specific position. So for example, these ones, they are not basically trained to follow one, but if I were to put a basic program to just simply run the motors, and I can be able to monitor the speed of these motors. Yeah, I can be able to monitor these motors. Let me see if it will work. So we have a basic screen, which is a terminal, which can be able to show me currently the speed of these motors. Oh, I'm very sorry, I forgot to mention, we have speed encoders, so that can be able to detect the speed of the robot, at which speed it's moving. So we can regulate the speed, whether to move slow or fast. Yeah. Currently, in our labs, we have more automated systems, like sensors for detecting level of water in a tank, controlling air conditioning units. But what we don't have is the current technology whereby we are talking about machine learning and neural networks. For example, neural networks currently is being used in security systems, whereby you come, it identifies your face, and it can only open the door by identifying your face. And since we are talking about corona, and we don't want physical contact, then we can use cameras on this machine learning. So it's one of the latest technology. Basically, the main purpose for this is machine learning. Yeah, just to train a robot to do something without you being there.
Good afternoon. My name is Bibia Mahmoud. I'm in the School of Engineering and Technology, the Department of Electrical and Electronics. I'm a technologist in the department, and we know that we are hosting our second Multidisciplinary Innovation Week, and our theme is on sustainable development and industrial partnership. We have our 3D printing and robotics lab. This is where we are hosting this particular activity. We thank the Alliance Française and Campus France for the partnership with TUM. For it is through them that we've gotten to receive these 3D printers and the robots that we are using with our students. This particular 3D printer is very important in the sense that in the current technology that is ongoing, the 3D printing technology is one that is being used widely. We all know that we have some equipment that are very expensive and are within the university, and some parts of the equipment get worn out or destroyed or broken, and it is very difficult for us to get other ones or contact the suppliers so that we could get the parts. So with the 3D printer that we have received, we can print those parts for use. Hence, most of our equipment that were down or have been put back to store since they cannot operate can now be taken back to operational. It is also important in the sense that all our students usually do final year projects, both diploma and degree students. And as they are doing their project, they design prototypes. In most cases, they're using boxes to design, or wooden blocks to design their casings for their projects, making them not well representable. With a 3D printer, they can be printing the casings for their prototypes, hence making the prototypes more presentable, and we can send them for competitions outside the university and also in the industries for display. So it's very important. We also have the robots that we received from Alliance Française. These robots have great use. We all know that current industrial sectors or in current industries, PLCs and robotics is the current technology that is being used, and our students should have knowledge on that. So these particular robots that we have received are going to improve their knowledge of robots and also enable them to know how to program, particularly in industries where they need to program the machines or the plants to achieve a certain output in terms of production. So they have to learn programming languages, which is C++, and they're going to learn it in the process of using these particular robots. We all know that our mission is, and our vision, it's on the development of science and technology and advancing science. So if we are as par with our vision and in application of our teaching to our students, if they can be competitive enough when they go to the outside market by applying the current skills that are used, that is robotics and 3D printing, then as a university, we are going to be very happy, and we all know that employment is not easy nowadays, and we need to empower our students, especially the female students that are in the field of engineering. So I'm going to have some students demonstrate how important and explain how they can use the 3D printers that we have received just the other day, and also the importance of the particular 3D printers and robots in their day-to-day learning activities. Thank you so much.
Okay, my name is Kipkor Kidion from the Department of Medical Engineering, and my innovation is diagnosis of malaria using machine learning. Okay, where I was attached during the normal industrial attachment, I realized that most of the diagnosis of malaria is the use of conventional microscope, whereby the lab technician usually observe the prepared slide inside the microscope, manually checking the microscope to see where there is virus, not the virus but the bacteria. But I realized that there is need to innovate in order to solve the problem of manually checking the slide by using machine learning. So I realized that there is need to capture those images, and these images is trained using machine learning. And then once the model has been trained, then the model is extracted, and then later I build the software. And this software is able to detect the presence of malaria, not only the presence of malaria, but to an extent which type of malaria, because we have 5 types of malaria. And this system is able to detect the presence of 2 types of malaria. That is the Plasmodium falciparum, which is the common one, and we also have Plasmodium falciparum. So I realized that once you train a model, it will be able to avoid the biasness, because as human beings, sometimes we are biased, because they normally say experience is something very important in anything, because if you have experience, definitely you are able to identify, to spot where there is bacteria. But computer is not biased. So once you train the model, it will be able to learn through patterns, because it will be following a particular pattern. So once the computer has trained and is able to identify those patterns, it will be able to tell you which type of parasite, that is either falciparum or the Fifax. Because for the falciparum, it is the one which is so much intense. At the same time, the shape of the shape inside the slide is banana shape. So the computer is able to identify which type of parasite, because it will see the pattern. If it is banana shape, it is able to see that pattern, and it will be able to show that this is a type of malaria, that is Plasmodium falciparum. So with that, I can demonstrate how the model works. Patient details is usually confidential. So someone who will be using this software is able to create an account, because not all people will be allowed to use the software. So someone who will be using it will be able to create an account. Once you create an account, you are able to register. Once you register, you can now perform the diagnosis. Someone who will be using this software should be able to create an account. Then you log in with the normal details like the username and the password. So I'm just creating a simple account. And then it will be able, in case you forget password, it will be able, you are able to reset the password. So first of all, when you are creating an account, you have to enter the security question, because most of the softwares, in case you forget password, you are supposed to reset it back. And for you to reset it back, you should be having the security question. So I'm just setting my security question. So which town were you born in? Let me just say my town. And then we also have the product key, because even for the Microsoft, for the Windows, you should be having the product key in order to activate the Windows. So for me, I'm also supposed to provide the product key. Then once you click sign in, you are able to log in. So let me just log in with the account that I created. So once you log in, anybody who will be using this software, because once you log in, meaning that you have the credentials, then you have to enter the patient's details, because patient details, in order to be saved into the database, so you should be having the patient's details. Like, let me say the patient is my name. And then age, we have the first name, other name, and the gender. And then you save the record. And then once you save the record, it will take you to a different window whereby you are supposed to open where there is those images. So I'm just clicking open folder, and I'm supposed to view those images, because once the images has been taken, it will be saved into different folders depending on the patient details. So I'm just clicking where those images are. So let me just click the first one, because I have a set of images. So let me just choose any image. And then once I load the image, the software is able to detect. And you just have to click a button. So once you click a button, it will be able to show you where the details of the patient and the status and accuracy. And according to this prediction, the status is Plasmodium falciparum, and the accuracy is 100%. So once I predict, or the system predicts, you just have to upload the records, because maybe in the near future you'll be using those records to make a clinical decision. So you just have to upload, and then in case you want to upload another image, this time around, let me just choose an image which is not infected, because inside here I have two sets of images. We have the one which is infected and the one which is not infected. So let me just use images which are not infected. And then I upload to the software. The software is able to detect. And this one, the status is uninfected. And then the accuracy is 97.142%. So once you make diagnosis, you can upload to the database. And then in case you now want to make the clinic, because you'll be performing a set of diagnoses. Now you want to see which image was having this malaria and which one was not having malaria. So you just have to query the database, because everything is saved to the database. So you just have to click a button, and it will be able to show you all the diagnoses that you made. Like, since we made 2 diagnoses, the first one is Plasmodium falciparum, that is 100% accuracy. The second one is 97%, but it is uninfected. So this software will be aiding the medical lab technicians. Instead of manually checking through the microscope, the software is able to make all those diagnoses. It will be able to see these patterns, and it will be able to diagnose. And this software is very important, because as you can see, with technology, there is prospects of using AI. And AI is something, it will be replacing human intelligence, because we have artificial intelligence and we also have human intelligence. So this artificial intelligence will be trying to mimic how human brains work. Because in order for you to make a decision, you should be having something inside your brain, like the pre-knowledge. And this pre-knowledge is what artificial intelligence is trying to mimic. I believe with this software is able to make accurate diagnosis, because it will avoid biasness, and it is very, very important. Thank you.
My name is Willie Jasin. I'm a 4th year medical engineering.
My name is Kipori Kijon. I'm a 5th year student awaiting graduation.
My name is Jim Murungi Gitonga, 5th year awaiting graduation.
Our innovation is a medical ventilator that we developed during COVID-19. There was increased demand for medical ventilators as most companies in the Europe resorted to manufacturing ventilators. So there was need for us now to use the locally available materials to come up with a ventilator. So I will demonstrate for you how it works.
Okay, this ventilator is using the BPM, the back
mask valve.
Okay, so this ventilator, when you put it on, it will be able to be compressing the back. So as it is compressing, it is dispersing the air that is inside. This ventilator has two inlets. One of them is oxygen, and the other one is the normal air. The normal air. So the cylinder will be connected to one of the cylinders, one of the piping, and then the other one will be connected to the normal air. So this oxygen that is from the cylinder will be passed through the ventilator, through the piping, and it will be able, we have the motors that has been created in such a way that it will be running concurrently. So as it is running concurrently, it is compressing this oxygen inside the bag. So as it is compressing, once it is connected to the patient, it should be able to be just supporting the patient to breathe. So on the demonstration side,
yeah. Also, there is a part of FiO2, which is a sensor for measuring the oxygen. In case one of the oxygen is not enough, there are two relays that are supposed to power on. If one is not enough, it's supposed to allow the other one being remittent, that it can allow the amount of oxygen required, because on the first screen here is supposed to monitor the oxygen amount. If the oxygen is not enough according to the patient body, then it will be able to power than you need the system, and the oxygen will be powered more. That you realize COVID patients require oxygen. So it will be able to calculate and say, okay, this patient needs this amount of oxygen. So even the motors themselves can be actualized or be activated to power more of the oxygen.
Okay, on this other screen, we have where we'll be monitoring the respiration rate. We have the IE, that is the inspiration, expiration rate. We also have the what?
RR.
The RR, the respiration rate. So like normal patient depends on the age, because for the young people, the breathing rate is usually high. So this ventilator is able to be used either for the young, that is the children, and then for the adult. So because we have these modes, we have for the child and then for the adult. So
we'll demonstrate it for you, you see. We are powering the system. The motors are first checking. Already actualized. It's showing me it is going at 47 ml. Then the oxygen is at 20%.
So we'll be using this as our test plan. So we are able to select if you are ventilating an adult or a child, an unit. So we have knob selection here. So right now we are ventilating an adult. We can turn it to do for a neonate. Then you're also able to adjust the tidal volume. And also the RR.
Respiration rate, because for the child, the respiration rate is usually high. That's why this is the child. It's moving faster.
And you might be wondering, what is this balloon? This one is a model of representation of the lungs. This is how the lungs are getting pumped in, pumped out, pumped in, pumped out. And the part of the kind of volume here is to ensure that the lungs are not empty, because you can't empty the lungs. When you empty the lungs, they collapse. So we ensure there's some minimal air left so that the lungs can't collapse.
Yes, so our innovation is addressing manufacturing and affordable healthcare. So So we recommend the government to actually pick up this idea and start manufacturing ventilators locally. Our message to young students, to new students is, it's either you innovate or die. Each and every sector is affected by technology. So the only way to survive is to innovate. Thank you very much.
And also, again, as we finalize, is that while we are developing this, we also developed another product of machine learning. It was comparing pneumonia images, again, normal images, and COVID images. You realize right now, you might go to an hospital, you test positive for pneumonia, but yet you are told it is COVID, right? So we built also another machine learning model software, even if it was not used anywhere, but we built it, we have it already, that could be able to tell this image as pneumonia, this image as COVID. So it could be able to tell the difference between pneumonia and the COVID. So those were the two products we came with during the during March to April period. Yeah, thank you very much.
Good afternoon. I want to welcome you to Technical University of Mombasa, the Innovation Week. We are doing this in partnership with Alliance Française, and they are supporting this because we have an MOU with the Alliance Française and getting the support from the cultural section of the French Embassy. We are truly grateful and very proud of our students who are very innovative, and with this kind of partnership, we see a bright future for our students and a bright future for our country. Thank you.
My name is Professor Peter Gichangi, Deputy Vice Chancellor, Academic Research and Extension. I would like to speak a little bit about innovation. And who is an innovator? We have several innovations, and many of us, when they think about innovation, we think about IT, computers, and things like that. But innovation is beyond just technology, because you can improve things, you can improve the way you are doing things, and that will constitute an innovation. So at Technical University of Mombasa, we pride ourselves as a technical institution, and therefore it translates knowledge, which we run as students, and which we execute as faculty members, to come up with innovation. So we do have several innovations which have won awards globally, but we pride ourselves because the innovations address certain solutions which are found amongst our community and within the university. So to approach the teachers who then mentor the students to be able to come up with this innovation, we provide the environment. As you may know, we have about 15,000 or so students, both from certificate, diploma, degree, and postgraduate level. And innovators could be any of those kind of students we have. Being a technology-based or technical-based institution, then it is very appropriate that we are able to translate the skills we learn into something which can solve a problem as an innovation. By the time I joined this university, I knew it was known for one thing, being a source of innovators. And that has continued to be true for the 18 months I've been in this university. So indeed, it's to take this opportunity and ask Kenyans who think about an institution where they can be nurtured to come up with innovation to consider Technical University of Mombasa. As we launch this virtual innovation, we appreciate one reality, that COVID-19 pandemic has taught us different things. And the new norm is here to embrace technology to be able to do things. And as an institution, we have decided that although face-to-face interactions may be limited, we can take the opportunity then to do this virtually. And therefore, the reason why we are going to have this virtual innovation day and week to showcase what we have developed as a university. So it's easy to welcome our stakeholders to join us to be able to participate in this innovation day, and it will be extended so that we have interaction with our stakeholders. I would like to mention particularly the French government, which we are working very closely with. They have given us robotics, they have trained our teachers on robotics, and many other areas of collaboration, which will contribute one way or another to enhancing our innovation capability. We do have other partners, Belgian government, we have mentioned French government. We do have our own collaborators
within Kenya, whom we work very closely with. And so with that, then for me is here to wish our exhibitors a very good exhibition week, and for our innovators to continue the spirit of being interested in innovation. Thank you very much.